Good morning, good afternoon, good evening, everyone. My name is Sai Venom, and I'm the offering manager for IBM Cloud Schematics, as well as our Terraform provider. Today, I'm really excited for a awesome, exciting session on Terraform. Now, a lot of you have probably heard about Terraform, but if not, you probably definitely heard about infrastructure as code. We think it's crucial to where our key customers, as well as developers in general, are moving forward. Just to start with a quick analogy, these days you wouldn't find a single developer who's writing code without storing it in some sort of SCM. And that is generally tends to be GitHub, but you really won't find any developers who are purely storing code on their local machine. And I think infrastructure and automation is heading in the same direction, where in the future, you really won't find any developers that are going into the cloud and clicking on knobs in production environments to configure. You're going to see them managing their infrastructure as code. And what we want to talk about today is one of the key strategic competitive solutions out there that's completely open source, Terraform, and it's one of the key capabilities that IBM has backed for infrastructure automation. Now, some of you might recognize me from some of the YouTube videos that I do. I actually do have one on Terraform Explained, which is a 8-minute explainer video on Terraform, but it doesn't come even close to the depth that we're going to be covering in Terraform today. And especially what we're going to do, what we don't do on YouTube, is tie it to the IBM Cloud use case, tie it to key customers, and kind of how it kind of helps us internally. So for an internal audience, we really hope that this explanation of Terraform is going to go further and beyond. But if you want to just sit back and watch a video with your coffee in the morning or something like that, please do check out some of the videos that we've uploaded on things like Terraform Explained. We also have one on what is infrastructure as code. So the two major concepts for infrastructure automation that we're going to be covering today. If you want to just watch a video later on, please do that as well. But today, let's get back to the topic at hand. Terraform. On your mark, get set, automate. Let's get going. Now, what exactly is infrastructure as code? So infrastructure as code is essentially the process of managing and provisioning cloud environments, whether it's public infrastructure, private, and whether it's on-prem in a cloud, and it does so through machine-readable definition files. And the key distinction here is that it's automatable scripts rather than going into the GUI, like an interactive config tool, and clicking around in the UI. It's taking all of those changes that you can do in the UI and then pulling it into the actual template instead, into a machine-readable, repeatable file. Now, infrastructure as code provides a number of key benefits towards users, and these are things that we're going to drill into more as we get through the presentation. But the key one right off the bat, automation, in general, just reduces costs. As you automate more things, you have less costs associated as operations teams need to spend less time kind of going through and clicking through different capabilities. In addition, let's define a few key things here, things like config drift. Config drift is when, say you have a Wikipedia file or a set of instructions on how to set up your automation, and someone ends up going into the UI and making a change, but then doesn't put that instruction back into your automation. You've essentially experienced config drift where, say, there's a disaster and you recover your environment and you're following your set of instructions in your wiki or your automation script and something doesn't look right. Well, now you have to go figure out what actually changed, and infrastructure as code essentially enables you to avoid that entirely. In addition, you get the improved security and compliance, as well as the ability to align with DevOps best practices. Today, you won't find anyone that's using developing code without GitHub, right? So just the same idea with infrastructure as code. You want to make sure that your infrastructure automation is in place, in automation, and repeatable. So let's get started with talking about some of the properties of Terraform. Let's talk about some of the key properties of Terraform, right? The qualities that make Terraform so truly unique. And I like to start with an analogy for the first one. It's the difference between imperative versus declarative languages. Now, The analogy here is that in an imperative approach, it's like getting in your car and doing every step of the way to get somewhere, right? So you take a left turn at a stop sign, you get on the highway, you take this exit, and you turn left. Now it seems fairly straightforward, right? You follow a set of instructions and you're there. But I think anyone who lived before the age of GPS can attest that although these instructions might seem easy, you mess up one step along the way, and now you're in problem solving mode. You're trying to figure out how to get right back on the right path, and it's not quite so easy. Now let's talk about a declarative approach. This is basically calling a taxi or Uber or Lyft with the destination already loaded, and then you get in your car and they take you there. All you have to do is get in the car and get out. That's all that you need to do. Every step along the way is handled for you. Is a highway blocked? That's not your problem. The GPS or the driver has to deal with that and figure out how to get around that blockage. Now, the difference with imperative and declarative when it comes to automation is the same thing. When you have a set of scripts that automate your infrastructure in a step-by-step fashion, now this is what most people are actually familiar with. Say you want to deploy an application on IBM Cloud. What are the commands you run, right? This is the first approach most people think of when they think, I need to automate this. IBM Cloud login with an API key. IBM Cloud KS cluster create your IBM Cloud Kubernetes cluster. Then they need to deploy their application, so they run a line for that. And then they need let's say, a MySQL database for data store, so they create the service. And then they connect the service to their cluster. So these are all incremental steps. Now that might be a very simple automation script to write, right? In your mind, you're thinking, oh, that's just 6 or 7 lines. You stick it into a bash script, you're done. What happens when one of those steps fails? Do you roll back all the steps that ran successfully? Do you pick back up of where it did fail? I mean, now you're starting to do error handling at every step along the way. That simple script is now becoming incredibly complex. Declarative languages solve that issue exactly because you declare the resources that you want ahead of time. And we're going to demo this. We're going to show exactly how you do this. You declare the resources that you want, and then you can run that as many times as you want. You're going to end up with the same thing. And here's the key part. If one of those steps fails, well, the next time you run it, maybe you make an edit to the config file, it's not going to redo the steps that ran successfully because it makes sure that the state of the world matches the state in the config. And it just makes the changes that you want. But this actually brings us to the next property of Terraform, and that's idempotency. And that's the property of an operation, generally in computer science or mathematics, where you can apply it multiple times without changing beyond the initial application of that execution. Let's dumb that down a little bit. Basically, you run the same Terraform script 100 times or once, it should result in the same thing. Granted, no changes have happened in the infrastructure or platform. And this idea of idempotency enables you to effectively manage your infrastructure automation scripts, allowing you to avoid that config drift that we talked about, because now that you have this kind of capability to update infrastructure just by changing one line of your Terraform automation, you can make a change to your infrastructure. So now you're thinking anytime you want to update the number of clusters that you have or a number of worker nodes that you have, you just flip a switch. Now, those are the two key capabilities, properties of Terraform. That is idempotent and a declarative language. Now, let's quickly talk a little bit about what Terraform is. Now, it's an open source language. It's created by HashiCorp in 2014. It's written in Golang and has a pluggable architecture. And we're going to get to that in a minute here and what I mean by a pluggable architecture. But there's 4 major lifecycle events that happen in Terraform. First, you develop your template. You write that template out and you figure out, what you go to documentation and you say, okay, this is what I need to establish a Kubernetes cluster. This is what I need for a cloud object store. Basically go to the documentation and you click copy, paste, copy, paste, copy, paste, and you make sure everything looks good. And then you do a Terraform plan. Terraform plan, what that's going to do is basically tell you what's going to get created. It's going to show you every step of what resources are going to get actually provisioned. And you hit the apply to actually create it. So this is when Terraform goes out to all the APIs in your cloud, uses your API key to make sure that it's authenticated to create the resources. The final phase of the lifecycle, infrastructure changes. Go to your Terraform config, make an update to one of the config files, and run another apply to basically update those set of infrastructure. Now, we talked about how Terraform is pluggable. It's pluggable through these things called providers. Providers provide essentially an abstraction layer for cloud providers. So think about things like PaaSes and SaaSes and IaaS. So, anywhere from IBM Cloud's IaaS layer, software, to things like our software platform offerings, and things like Cloud Foundry out there has a Terraform provider, as well as SaaS offerings, things like Cloudflare, pure SaaS offerings. Also, sometimes they'll write and provide Terraform providers. Now, the reason this is important, the reason why the pluggable nature of Terraform is so important, is that they basically kind of outsource the capabilities that make Terraform so effective, because every cloud has their own set of APIs and SDKs that make it truly unique. Providers take that and basically enable you to write HCL, HashiCorp config language, to develop Terraform templates. So you're going to find providers for all sorts of different solutions out there, competitor clouds, software, RabbitMQ, everything you kind of see on these lists and you can see online, there's going to be kind of providers for. And they're either maintained by HashiCorp or the community. IBM has made the strategic decision to have ours maintained by the community rather than HashiCorp. So you're going to find ours in the community provider. The IBM Cloud provider, it's fully documented in our IBM Cloud docs, has the support for over 100 resources on IBM Cloud. A few of those are kind of highlighted here, things like VPC Gen 1, VPC Gen 2, Cloud Foundry, IBM Cloud databases. We've got resources and data sources that enable you to automate all of these capabilities. And we don't have 100% feature parity with the API and CLI and provider, but we're getting there. And that's kind of part of what we want to focus on today as well. Quick overview into what HCL looks like. Here's an example of what a Terraform config file can look like. So you've got things like, right off the bat, the provider. And we talked about this. This is the pluggable architecture of Terraform. We say that this template requires the IBM Cloud provider to work properly. And that basically enables a host of resources to start working. So on the right side, we see IBM Container VPC Cluster. That's a custom resource created by the IBM provider that enables this Terraform execution to work with IBM Cloud. We see a couple other things like variables, data sources, and an output file. We'll talk about this in a minute here in more detail. Do definitely want to get to a demo today. So that's the part I want to really focus on, the demo. Now, what I've got here on my local machine is a very simple Terraform file ready to go. Now, if we look at the actual Terraform file, I've got it sourced in my VS Code, but in the IBM Cloud Terraform provider repo, the official repo, we've actually got a folder full of examples on how to do everything, pretty much everything that you might want to do on IBM Cloud. We've got examples for. In addition, other teams in IBM have been working on creating really cool modules to help you work with IBM Cloud. The Garage team has been working on this, the GCAT team. And we're actually working to get all of these modules and examples sourced into the IBM Cloud documentation so you have a single place to find these. For now, they're in this examples repo. So what I did was I wanted to create a cluster. So there's multiple ways to create a cluster, whether it's rocks, VPC Classic, VPC Gen 2, or just straight up Classic. And I cloned this repo to my local machine. So let's take a look at what this Gen 2 cluster example looks like. Now, I want to point out the four major files that we've got here. A main.tf, it's kind of like your main execution environment. The outputs, variables, and versions. Starting with the versions file, basically says make sure you're using Terraform version 12, 0.12. Now, here's one thing that I want to clear up. So when you see any sort of versioning scheme that starts with 0, you know that there's going to be breaking changes. Now, there was recently an upgrade from 0.11 to 0.12, and that broke a lot of the configuration for people. So they had to kind of do an upgrade migration. And better believe that there's going to be more breaking changes in the future as well until we see a one dot release that's exposed. And this isn't to say that Terraform shouldn't be used in production. Terraform is being used in production by a number of major companies and customers, as well as by us. So that's not to say that. It's just to say, keep in mind that versioning you're very kind of careful with and maintain whenever upgrades are required. Just to be kind of frank, the upgrade from 0.11 to 0.12 was fairly straightforward. They even had a little handy helper tool to help you do that migration. Now, let's go to the main.tf file. Right off the bat, we've got the provider, the IBM provider file that kind of is our plugin to help us work with IBM. In addition, now we mentioned that Terraform is a declarative language. So we just basically declare the resources we want. They're not in any specific order, but these are just the resources that we want. Sometimes they do need to be in a particular order where some resources are dependent on others. So you'll need to structure the file a certain way. But in general, for example, if I wanted to, I could switch these two. Doesn't really make a difference because that's just establishing this resource. Now, I won't go into too much depth here because I am kind of running out of time for my section here. But essentially, these resources dictate what kind of configuration we're creating. In this particular config, we're creating a VPC cluster, and then we're creating a custom worker pool in that cluster. Then we're creating a cloud object storage instance, and then binding that instance to the cluster. So pretty straightforward. Now, as an operations team, if I want to configure this, I go to the variables file. This is the best way to expose all your configuration in one easy to access place. So if I want to change the number of workers in my pool from 1 to 2, I can just change it right here. Or change the cube version, name of the worker pool, whatever I want to have configurable, I generally want to put in as a variable and then refer to those variables in the main file. So, use var dot to do that kind of reference. So now that I've got this Terraform file, let's open it up in a terminal. And I've already kind of loaded into this folder here. The first part of the life cycle, as I mentioned, was the plan phase. So I'll do a Terraform plan. And you'll see what it does here is it refreshes the state. So we've got the state on my local machine and the state in IBM Cloud. It's going to go figure out what's in IBM Cloud so it knows what it needs to change. All right, it's got the state back. It's basically saying, you see all these green plus marks? It's basically saying we have to create everything because you don't have anything in IBM Cloud yet. So let's do that. We'll do a Terraform apply. Now an apply actually also does a plan. You could route the output of a Terraform plan into an apply, but I'm not doing that here. So I'm just doing a Terraform apply. And so it's going to refresh that state again and says, okay, are you sure you want to create 9 more resources? Yes. So this is actually going to use my API key, which I've set as an environment variable. And it's going to go and do all of that creation step by step. The first thing it's doing here, it's going to create that cause instance. And that's a service in IBM Cloud. Now it says it's still creating after 10 seconds. And it's also creating a VPC at the same time. So, it does these both dynamically and concurrently because it's able to, because it knows that those two are not related or dependent on each other. Going to my cloud account, I go to my resource list. Now I should see that brand new created cloud object storage instance. So if I go to storage, my service right here is the one that I just created. And we should see that it created on today. Let me actually go back so I can show you guys the timestamp. There we go. Created June 30th, 2020. And it was automatically created through the automation script here. Now, the remaining step is to create the cluster itself. It seems like it's created the VPC. Next, it's got to create the cluster. So if I go to my Kubernetes dashboard, I should see that it's in create phase. There you go. This cluster has just been created by the automation. Here's the cool part. This template isn't going to come back until IBM Cloud says this cluster is ready to go. It's not going to say, okay, I did my job, you're done, go ahead. It's going to make sure that this cluster is ready to use before it comes back. So that means if you need to build additional automation that relies on Terraform, say you want to use something like Ansible to do deployment of the application itself, tie that into your Terraform script, make sure that the cluster is up after the Terraform script is done, then kick off the Ansible portion. That's a key piece of automation that you could set up. So that's the demo that I wanted to kind of show you today. Now, the next part that we want to get into, I want to introduce Albie Joni, who's the SDSM team lead on IBM Cloud Schematics, as well as the Terraform provider team. I want to have him quickly introduce the provider and some of the key capabilities here. I won't take up too much more time here. Without further ado, Albie, please go ahead and
Sure.
introduce yourself.
Thanks a lot, Sai. So as I was mentioning, I have the technical lead responsibilities for schematics and Terraform. Sai, you're able to hear me, right?
Yes.
Okay, great. Thank you. So I think till now what we saw was what is Terraform, what are the benefits of it, and how as a user you can use Terraform to configure your provision your infrastructure and configure them. Now, next part of the session discussion was going to be a one step deeper, one step inside, as to know if you are a contributor, if you are a developer of Terraform, Terraform providers, in this case, IBM Cloud Provider, what do you need to know about, right? So I think so this picture kind of illustrates from left to right what happens, right? So you have the Terraform files, the main.tf provider variables. So the site kind of showed us a few examples there, and then we ran the command line tools like Terraform plan, apply kind of commands. And when we did that, what really happens is that call comes in to to our provider. So since the provider was defined as IBM Cloud, so immediately it comes to the IBM Cloud Provider, and the IBM Cloud Provider has a mapping which maps which resource should I call. If is it a cluster resource that I have to work with, or is it a object storage resource I have to work with? So that call gets routed to the appropriate resource. And each resource, so you need to understand these as layers, right? From the provider, the next layer is a resource layer, or it could be a data source layer. And then the call goes to SDKs. Now, I think it's an important aspect of Terraform where they say that always talk to the cloud via the SDK. So the resource layer talks to an SDK and uses the SDK to perform the appropriate functions in the backend APIs. So these are the layers that that a Terraform developer or a provider developer has to keep in mind when they are going about doing it. So let's go to the next slide, where we will see the list of files that you will be really touching. So on the left-hand side, you see the list of files that you will be really touching whenever you are planning to develop a resource. So there's a provider and the provider test, which basically helps you define the schema at the provider level. So some of the schema items, like for example the API key, the resource group, the region. So these are these are the attributes that are defined at the provider level, and these attributes are passed across to the resource, so the resource can use them going forward. So a provider is one file that you kind of you need to understand. Some changes needs to be made. For example, if you're adding a new container cluster, then on the right hand side you see you need to have a data source for them. You may have a resource, one or more resources added, and you may have a few validators to be added. So this is what you define in the provider.go, where you specify this is how it maps to, right? And then go to the next slide. So there is a configuration file where you specify what is the API endpoint, or what is the API or SDK that I'm going to work with. So in this case, for container service, there are two versions of the SDK. So and both the versions are available. In certain cases, it goes to V1, certain cases it goes to V2. So that's the reason why we added both of them. Now, I think the next slide. The next two slides are very important, because here is where you add the meat of what Terraform does, the meat of what IBM Cloud Provider does. The data source.go and the resource.go. So in the data source.go, it actually maps to the data block that Sai was showing the previous slide. So in the data block, you kind of specify that please read all data associated with a particular cluster ID. So it basically reads the data, reads the information about that cluster. So you implement the reader function in the data source, and the reader function uses the SDK to read out the information and fill up the schema. So you can use the data source to read information from the backend thing. And once it's read, this information is stored in a state file. So because Terraform maintains a local state file, all this information is kind of stored in the state file. The next slide.
If you don't mind, I just want to quickly cut in here to show folks what that actually looks like, right? So, when we did that Terraform plan, we actually basically told the Terraform CLI to read into exactly what's in IBM Cloud. So those set of schema that we saw there, are basically saying, here's the schema that it's going to read. Some of those it's kind of already set. Some of those it's going to be known after it does the apply phase. And that actually all gets loaded into a state file that we can see here, terraform.tf state. And that state file kind of has the information. Now this one is kind of bare bones because right now there wasn't any resources for this particular execution. But if I saw the other one, CDVPC Gen 2, that's for demo, we can see that all of the schema in IBM Cloud, things like the CRN of the IBM Cloud provider cost instance, and all of those schema are basically loaded into that state file. So sorry to interrupt you there,
No
Albie. I
problem.
just
So that's
wanted
really
to
helpful.
yeah.
Yeah, that really helps, right? So the data source basically reads the data and that data is available as part of your configuration. So one resource could refer to another resource. For example, you need a cluster config. For a Kubernetes resource may require a cluster config so that it can execute some of the kubectl commands. Or the Helm provider may require the cluster config. So you use data source to read data from the backend cloud. So and the next slide is the resource. So this is another. So as a developer, so this is a place where you probably do the meat of your work. So you need to provide functions to create, read, update, delete. So these are functions that allows you to create. For example, allows you to create the resource. In this case, create a cluster, and this create function is going to wait. It's going to initiate the create API and keep polling, saying that no, is the creation complete? Is it complete? And there's a timeout that you see right below. So until 90 minutes, in this case, the creation will be, it'll be waiting, right? Because sometimes, the ALB and other components, for creation takes quite a while. So you can override the timeout if you really want. If you really want to reduce it or increase it, there are ways to override the timeout. But the default timeout is what is getting programmed here. So creation, likewise, read is similar to data source. So in this case, you are reading the resource information. Update, I think update is an important aspect. While updating the resource, there are some times when you update the resource, you kind of reprovision the resource. There are some attributes of the resource. For example, private VLAN, if the ID has to change, you can't continue, you can't just go and update the private VLAN ID in a cluster, right? So, but then number of number of workers in a worker pool can be updated in place. You really don't have to reprovision the cluster. So there are updates that that are done in place. Then there are updates that require you to reprovision. I think I'll show you how why that happens. And similarly, delete is a function that goes and deletes all the resources and the dependencies associated with it. Exist, verify whether the resource exists. Importer is a function that you add that enables you to import a resource into the state file. So this is like a discovery capability. Not all resources can be really discovered, but importer allows you to do some amount of discovery or discovering the configuration from your backend cloud. So this is where you write the meat of your function, and there's quite a bit of work that you do to develop the resource when compared to the rest of them. And the last slide is a validator. So okay, I'm sorry, I think I missed this. So this is about if you look at the schema, there are some attributes of the schema that I just want to highlight. So some attributes are marked as required, optional, that's obvious. Some are marked as computed. Computed means the user is not providing this, but the system reads it, right? So after you create a cluster, the worker info is worker info, which includes the ID, the version, the pool name, is computed and returned back to Terraform. This diff suppress function are functions that that you write that allows you to know. So because what happens during planning, Terraform planning, what happens is that it compares the desired state, which is your Terraform file, and the current state. The current state is the state file. So and then it kind of does a diff, and if there is a diff, right? If there is a difference between the desired state and the current state, there is the plan gets activated, saying that there's a change. The change could be an update change or a create change or a delete change. So diff suppress function enables you to suppress. For example, in kube version, I don't want to compare certain keywords so that I can suppress the difference, right? So that's the reason why we have diff suppress function. There are validation functions, in this case hardware, right? You want to validate whether the string is either shared or dedicated. Likewise, you can have validation function for all the attributes. Force new is what I was mentioning a little earlier, where if it is marked as force new, and if the values change, private VLAN ID changes, then the whole resource is reprovisioned. If a particular attribute is marked as force new, and if the HCL file of the desired state says that no, it has to be changed, then the entire resource get reprovisioned. And you can also mark certain attributes as sensitive so that no, it doesn't get printed in the log file, or it doesn't get no, it doesn't get printed in the log file and emitted in any outputs. So I think these are some of the aspects that you have to keep in mind when you're designing the schema, and working on the container cluster resource. So you'll be able to borrow some of this information from the Swagger, when you're referring to the Swagger or looking at the CLIs while you're designing your resource. The last one is about validators. So there are validators which basically validate the input data, and there is a set of generic validators that we are using, which basically validates whether a value is, there are min value, max value, min length, max length, regular expression, validation, etc. So there are validators out there. If a validator does not exist, you may want to add one validator. So these are information that for a developer who's developing a new resource, that and add it to the IBM cloud provider, and that's going to be useful for them. So I would like to introduce Suraj, actually, who has gone through this whole exercise, right? So he has developed around 7 or 8 resources for the power. He's from GTS, and he did all that in his free time, right? So welcome, Suraj. I think if you can share your experience with respect to developing the IBM cloud provider. Wendy, you want to?
Yep. Thank you. All right. Sai, you guys can hear me well?
Yes.
Okay, perfect. Okay. Let me quickly share my screen. So as Sai and Albi have very explicitly stated how it is to basically kind of get engaged into the Terraform community, I'd like to kind of share my experiences, right? So first of all, as Albi mentioned, I work in GTS, and in my copious free time, I've had the time, to kind of to basically go ahead and dabble with Terraform, right? We in GTS, especially the project that I work on, we are one of the biggest consumers of Terraform. And one of our goals was that, as we enable customer workloads to run on IBM Cloud, we had a need to figure out how to basically build a more standard platform for customers to come in, right? And we decided that we'll actually take the initiative and work with Albi, Harini, and Sai to kind of go ahead and start building a Terraform resource for the Power Cloud, right? And the good thing is that a lot of the Power Cloud stuff gels very well in with the IBM standard kind of model. So kind of let me just dive directly into this, right? So the way you want to kind of start working through a Terraform provider is, first you need to understand basically the concepts of REST APIs. I'm sure everybody who's here understands what a REST API looks like, right? So what we did was, the way you want to kind of get started is you kind of make these standard REST calls and try to understand what the structure looks like, right? Once you understand the structure, then the next level that you want to get into is basically figuring out how to write a sort of a helper SDK, right? That's one was that Albi was mentioning about, right? So the SDK would take all of your calls that you would make and kind of build them into smaller Go functions. And what we did was that we decided that we actually have something called as an IBM Power Go client. Sorry, that's not the right one, but an IBM Power Go client, which is right here. And then these Power Go clients would actually perform the same set of calls that you would actually have that would be done by an IBM Cloud CLI client, or when you make those REST API calls, right? So you first build the SDK that would interact with that service, and then that SDK is what you would incorporate within the Terraform code base, right? So when you're writing the provider, if I go back in here, when I go back into the provider, in the provider you have something called as a go.mod file, right? And this is all relevant for Terraform O12. Starting Terraform O12, they basically came up with this concept of using Go modules as you're building the Terraform provider. So we've got actually an SDK right here, right, which is the IBM Cloud Power Go client. And the Power Go client, as I said, right, is basically a SDK to talk to the Power service. So all the functions that the Terraform provider needs to use, you actually put it in there, and then that will pull all your code in as you kind of go in and build the provider, right? So what I'm going to do here is basically go ahead and say, okay, I'm just going to go build a provider here, right? And as you see, if it was a latest version of the Go client here, it would actually pull the latest version of Go client. So it'll do that, and then it'll compile it, and it'll work with it, right? For the sake of this conversation, what I'm doing is that, and as you get into the kind of, developing the Terraform provider, the way I've educated myself and kind of done this is actually I go in and build a data source first. Because what the data source allows you to do is that data source allows you to kind of get the structure of how you want to kind of write a Terraform resource. More importantly, the data source is kind of a non-intrusive, right? All that the data source is going to do is that you give it some values, and it'll go and try to pull information from the cloud service, right? So it is completely non-intrusive. It is non-destructive. It doesn't cost you any money or any resource to basically kind of build that up, right? So out here, I've actually created what I call as a kind of a cloud instance data source, right? So if you see this structure, the structure looks very similar to the response that was written from the REST API that I had before, right? So I've already built my Terraform provider. I'm just going to actually just do a kind of, I just want to do a TF copy because I have it in a separate file here. So I do that. So it's in there. And then now let me flip back here to my screen here, right? So in here, got the main.tf file, and in the main.tf file, I have these sort of, this is basically the name of the data source that I have. And you need to make sure that when you actually build a data source, right, this needs to be input in the provider.go, which is right here. So IBM Cloud Instances, right, which says, okay, this is my data source, and this is exactly what it should do. So I go back to my screen and do a Terraform init because I just rebuilt the provider. Do a Terraform plan, and what it's doing is that basically reading my main.tf file. It just refreshes state. All that is doing is just making a call to the IBM Cloud Provider service, right? That's all it's doing, right? Come on, IBM Cloud. Okay. State. Like watching grass grow. Okay. So you got a response back here. So pretty much what it does is that if you are a user of the cloud instance for Power, it will go get a list of all the LPARs that belong to you in that instance, right? And in addition, right, as it's getting the instance of the LPAR, it also provides you with enough data that says, okay, hey, what are the capabilities that exist in this cloud instance? How many instances do you have? How much instance memory, processors, and whatnot, right? So you can add all of this data depending on what response you get from the API. And it's vital to, the reason why you actually want to use data sources is because when you want to build a LPAR or you want to build a resource, data from the, obtaining data from the data source can be fed back into your resource. So that way you can actually run some checks prior to creating the resource. You want to actually check, okay, hey, is this user going over certain instance count or how much of memory has been consumed? You can actually write in a lot of logic within your resource based on the data that you get from the data source, right? So that makes it very interesting, and that's what it is, right? So but the takeaway from this is that whenever you want to kind of start building a Terraform resource, the way I would kind of advise you is start with a data source. So that way you get the experience of writing a Terraform resource, as well as, again, because it's not destructive, you don't have to worry about breaking anything, right? All that you're doing is just dabbling, right? So Sai, with that, I think I need to hand it over to Harini to kind of talk a little bit about the test automation
Yep.
in there.
But before that, yeah.
Yeah. So real quick, I'm going to do kind of a very quick overview of why we went through what we went through today. And Harini, I'll pass it to you here in a minute here. And let me share my screen one more time. And really kind of just let's talk through what we saw here today. Because we started with, what exactly is Terraform? And we talked about the life cycle of events and how as an end user you can use Terraform to manage your automation. We talked about the idea of Terraform being a declarative language rather than imperative, allowing you to say what you want rather than taking the incremental steps to get there, and then being able to very easily repeat that process. Now, all of this kind of goes to show that our customers and our users and the broader community out there are really digging Terraform. They're using Terraform as a way to automate their infrastructure, and we're seeing more and more that our clients are really putting a priority on this. Now, I go to say this just to say that the amount of kind of investment and focus that IBM has put on maintaining the Terraform provider and pushing our Terraform support is not in line with how much customers want it. In fact, I don't think we're spending nearly as much time within IBM as making our Terraform offering and provider as first tier as some of our other capabilities, especially when you're looking at how much our clients are demanding and using these capabilities. And, without kind of going into too much detail, I want to share a little bit about what our customers have said. And we'll start with some good here, right? They've said that they consider the IBM Cloud product, whether it's IKS or, VPC, whatever it might be, to be GA ready only if it can be included in our automation to provision and configure them using either Terraform or Ansible. Now, not to say exactly who this client is, but just to be kind of frank, this is one of our biggest banking clients right now. Now, some of the bad of what we're kind of getting back here. They're seeing that there's not enough parity between the features exposed in the API and UI and CLI and then the Terraform side of things, because they're going to have to go through docs and trial and error to figure out the differences. And more often than not, they've seen that the Terraform provider code can be out of sync with cloud services and resources. Now, this is a problem that's a result of just a lack of investment and focus in Terraform and the provider today. And to be perfectly fair, the Terraform provider and automation is fairly new at IBM when compared to our competitor clouds. Now, that being said, as of June 2020, we've got more support for more services in IBM Cloud than we've ever had before, but the team is only able to manage so much. We've got an excellent team that's maintaining the Terraform provider, but every time the API changes or a new feature is released, we're having to, for all of the various teams in IBM, whether it's IBM Cloud Databases or IBM Cloud Kubernetes Service, we have to go and program the updates and capabilities and features. And unless there's an automation pathway built in, a way that we're automatically notified and that kind of thing, and then even then, unless the team waits for us to make that integration before they GA their feature, which no one does right now. People GA the feature, and then we kind of rapidly work to include that support in the provider. But until we get to that state where the Terraform provider is a key part of the way you're approaching automation and the Terraform kind of asset in IBM Cloud, our customers are going to continue to give us feedback like this, because it's quite frankly impossible for our team to be able to keep up with the incredible amount of API changes happening across the board and all the services happening created in IBM Cloud. So here's a call for action on what kind of we can do to help here. And that's kind of what I wanted to get into here a little bit. Albi, did you want to, or Harini, did you want to walk through the responsibilities of what we provide and as a Terraform provider team versus what the cloud services teams we believe need to own?
Yeah, thanks, Sai. So I'll take over this. So now we'll see what are the responsibility between IBM Cloud Service team and a Terraform provider team. As IBM Cloud Service team, as per the new service framework requirement, we expect that the team should provide a Golang SDK and they should start developing design and start developing the Terraform provider. So they should analyze their APIs and like divide them into either data source or Terraform resources. So for each resource or data source, there should be an unit test file and then a respective documentation which explains what are the arguments and what are the attributes does the resource or the data source takes, and an end-to-end example where which it explains the provision and how it will be configured, how the service will be configured, and how it can be interconnect with the other services. So next to the maintenance of the Terraform provider, yeah, there will be a frequent updates on the IBM Cloud Service APIs. Maybe they will change from version V1 to V2. So it's a responsibility of the IBM Cloud Service provider team to take that responsibility. They need to periodically test the Terraform resources, SDK, and fix any of the defects raised by the customer. As a Terraform provider team, we help the initial IBM Cloud Service teams, like initially writing the Terraform or resource. So we will see it there with some of the initial momentum. They can start raising the PRs. So we'll review the PRs and we'll give you some comments based on the code. We will take up the responsibility of releasing the Terraform provider, like every weekly or bi-weekly, mostly we'll have a release. It can be a minor release or a major release. So minor means it's just a future request or any bug fixes. A major release can have a new resources or a new data sources. We will take the ownership of updating the Terraform core engine. So maybe in near future, the Terraform will be moving to 0.13. So we will take the responsibility of updating our Terraform IBM Cloud plugin to the latest Terraform. Sometimes we may handle the customer support tickets, which we get from the schematics or like that. So moving on to the next slide, yeah, here you can see some of the guidelines. So these guidelines explains what a developer should follow while designing a resource or implementing a resource, writing a unit test case or a documentation, and how to write an end-to-end examples. So now we'll move into the important one, the service framework timelines. So we started interacting with the service team in the 2Q 2020. So we started approaching the different IBM cloud services too. And we expect in 3Q 2020, at least they should review the current level of Terraform support which we have in currently, so that they can publish and develop a plan, and that needs to be approved by Terraform SPOC. In 4Q 2020, we expect all the IBM Cloud Services to publish an example and doc which explains how their service can be provisioned and what are the different arguments or attributes it's required to provision their respective service. So in 1Q 2020, we even expect like not only provisioning, there should be a Terraform support for configuring those services. So this is the Terraform like service framework timelines which we are following with the different IBM cloud services teams. Yes, over to you.
All right, thank you so much for that, Harini. And just a little bit more flavor that I want to put here, guys, is, when we look at the split of responsibilities here, essentially an IBM Cloud Services team is you. It's the teams that are maintaining the services, whether it's IBM Cloud Databases or the VPC team, or maybe it's App ID. These are the kind of services that you're developing and maintaining SDK. It's time to start thinking about developing and also maintaining the Terraform code. And the best way to do this from our perspective here, and if you guys are not familiar with it, the service framework is basically the framework for all service provider teams at IBM to follow to essentially make sure that there's consistency and clarity between services on IBM Cloud. If you were around when IBM Cloud was first launched, years and years ago, maybe 5-6 years ago now, when we were Bluemix, it was kind of the wild, wild west, and teams could kind of do whatever they wanted. There was very little guidelines and kind of approaches. And that experience was kind of really made aware for our customers who didn't really like that. Now, service framework, as much as service provider teams like to complain about it because there's so many requirements and capabilities and things that they have to do. At the end of the day, I feel like it's one of those crucial things that cloud needs to have to make sure that there's consistency and guidelines for the services. Now, this timeline kind of elaborates how we've inserted the Terraform requirements into the service framework timeline, and we're here to help you, support you through this process. The Terraform provider team has put in a lot of work to already start off the IBM Cloud Provider with hundreds of resources to work with IBM Cloud. So chances are you don't have to start from scratch. It's a matter of making sure your feature updates and changes make it into the provider incrementally. And so that's our call to action here. Make you aware of the service framework timeline, and it is a required part of the service framework starting in 3Q 2020. So make sure this is on your roadmaps, make an aha item for it, reach out to us. We're here to help you along the way. And in the meantime, we're continuing to maintain and update the Terraform provider, but we want to make sure that for Hamilton, for BNPP, for KP, for Geico, for AT&T, who are all using Terraform to automate on IBM Cloud, we want only good feedback from them. We want to enable them to use your services more effectively. We want to enable them to use more of your service. And I think Terraform is the way to do it and to make sure that that integration is tight and make sure that there's no issues with it and new features are pulled in as soon as they're available. Now we're coming up on about 5 minutes left. So with kind of some of the closing statements here, I want to kind of point out some key contacts. You can always reach out to me. At the end of the day, reach out to me on Slack and I can get you connected with the right resources. On this call, we also had Albi and Harini, who are the technical leads on schematics as well as Terraform. And you can always reach out to them for more technical questions. A full list of the team members, not a full list, but some of the key team lead members are also available here. And then the Slack channels here on the right side, you can see we have an adopters channel for teams that are looking to adopt Terraform and potentially contribute. We've got a users channel and then a Terraform channel as well. GitHub issues are always welcome on our open source GitHub issue board. We look at them regularly. If you have a feature request in the Terraform provider, just open up an issue and we'll get that prioritized. The number one resource, though, is going to be our cloud documentation. So definitely check out the cloud documentation for anything that you want to learn more about Terraform and learn more about what kind of resources there are. Terraform is one of those things that you definitely need to have documentation and good documentation. It's not something that you can just learn once and then figure it out along the way. It's not a simple programming language. You will need to refer to the docs. So we make sure that that is crystal clear. Shout out to our docs person, Nadine Spies, who does a great job on making sure our docs are up to date and working well. Now, we see a bunch of awesome questions in the Slack channel. Please continue to ask questions on Slack and we will answer them. But we have some top FAQs here, some top questions that people generally ask that I want to go through here. Real quick, as we're at the top of the hour with about 4 minutes left, there's a poll in the Blueprints-Talks channel. So if you haven't already, join the Slack channel Blueprint-Talks. It's an org-wide channel, so you can join in no matter what organization you're a part of. Please vote or ask any questions that you might have. Now, for this FAQ, now let's talk about a couple of things here. Now, a lot of people are asking questions about Ansible, which is another way to do automation, especially with our acquisition of Red Hat and our collaboration with Red Hat. Ansible is kind of the Red Hat approach to automation. In our view, Terraform and Ansible fit well together. Terraform is good for the automation of infrastructure, whereas Ansible is ideal for configuration management. Both can do the job of each other as well, but ideally, Terraform does well with infrastructure and Ansible does well with config and app management. So the IBM Cloud Terraform provider team actually also developed the IBM Cloud Collection for Ansible, which is a set of auto-generated code, actually based on Terraform, developed by Jay Carmen at IBM, to enable us to have and provide Ansible modules for working with IBM Cloud. Now, there are discussions in place right now for making sure that that Ansible support is more native, and we're working towards that as well. Consumers of IBM Cloud Provider for Terraform, all the big ones. It's safe to say. BNPP, Bank of America, AT&T, Geico, Maersk, just to name a few. I want to do a quick shout out to the GCAT team at IBM, which works very closely with customers who have very kind of specific needs and requests on how to use IBM Cloud and automation regarding that. So the GCAT team and Jen Val over on their end works very closely with these customers to shape and create Terraform solutions for them. And you better believe it that as a result of GCAP working with these customers, we get a lot of issue requests and idea requests and feature requests coming our way all the time. So, it's one of those things where it's a good and bad thing. It's a blessing and a curse because clearly there's a lot of usage, but that usage is driving more and more feature requests. All in all, that means we want even more of you to be kind of involved in the Terraform contribution process. Good segue to the next question. What's the effort required to actually develop and maintain your part of the Terraform provider? I mean, a medium complex resource, essentially, because we already use an SDK, chances are if you have an SDK in place for your service, written in Golang, it's about 2 to 3 person weeks. Now, those skills required are just going to be, Golang. So generally, we want that developer to be someone that's probably working on your CLI as they have a good idea of the APIs and SDKs in place. And those same skills can be used to apply towards the Terraform provider. Can Terraform be used to perform post-provisioning configuration of services and resources? Yes. So you can use the IBM resource instance to provision IBM Cloud services, things like CloudInt and that kind of thing, and then resources and data sources to actually configure those. How do you configure IKS or ROX clusters? Well, we've got a good set of documentation on how to work with Kubernetes itself. So, you use the IBM container cluster provided by the IBM Cloud provider to create the cluster itself. But then Kubernetes, the open source Kubernetes has a provider to work with Kubernetes directly. Does Terraform provision resources serially or in parallel? Well, Terraform can do both. And we've got a little bit more detail here. I just realized I'm on top of the hour. So we will send this deck out in the Blueprint Talks channel. Wendy, back to you to close out the session.
Wonderful. Thank you very much. With this, we'll end today's Blueprint Talk. Thank you all for participating and see you next time.